Well, hello everyone and welcome back. On the bench today we have the Clough Brengle Model 110 signal generator. Now this is a sort of a rare piece of equipment. This one's in pretty nice cosmetic shape from the other ones I've seen on the internet, which is only a few. There's not a whole lot of information on the internet on this unit, but this is a very nice looking piece of equipment. It is missing the handle, which here in the shop I rather have the handles removed anyway, because we like to be able to set other pieces of test gear up on top. But it looks good. It's got a couple of little nicks and scuffs around it. I'm not going to worry about doing anything with that because this has got that wrinkled paint on it and I don't want to do anything to mess it up. The label panel on the front's in very nice condition. Our dial looks very good, nice and clean, and no scratches or rubbed off marks on it. There is a problem with the center of it. I don't know if there's a bushing gone or the shaft's bent or whatever, but we're going to have to get in here and fix that. Now the 110 was made somewhere around 1937, 1938, and in its day it was the duck's guts of signal generators. This was what you would find in a lot of your repair shops that repaired equipment back then. It has a 4-step attenuation, a vernier dial for each step. This particular model goes from 100 kilohertz up to 31 megahertz. Puts out a signal at about 0.5 microvolts to I think 100 millivolts. Also has external modulation at 400 hertz. Now even something more rare than this piece of equipment is getting the original plug for RF out, and this was also sent in by the same anonymous gentleman that sent this in. Now this is made sort of like a number 47 lamp. So I get a good close-up of that. It just kind of sticks in and plugs right here into this slot underneath the vernier dial. So it's nice that he sent this with it, because I think I'm going to keep it stock just like it is and not change out to B and C like we normally would. Just keep the original cable with it. And even more rare than the cable, we have documentation. And you can see this came out in January 1939, and inside here it's got a lot of the alignment processes and different things about the generator, and also has the schematic. Now I have searched the internet for this documentation, and about the only thing I can find on the internet that has documentation is the original brochure that has been uploaded to the internet. I have uploaded this on my website. I scanned it in, put it in a zip file, it's actually a WinRAR file, and uploaded it to my website, and I'll leave a link down below in case you need to find this documentation. We'll have it. So pretty much what I want to do today is just do a teardown on this thing and find out what it's going to take to bring this unit back up to its factory standards of the time, and modernize the capacitors and stuff in it. We don't want to change no more than what we have to, because we want to try to keep everything as original as we can. But if it's old and out of spec, it's got to go and got to be replaced. So getting to this unit, we got several screws here that we'll need to take out. I'm not sure how many on the bottom of these has got to go. I'm pretty sure these has got to go. There's one screw on the back, but I believe it has something to do with, well, actually there's two screws here. So I'm thinking it's probably an RF box, RF shielded box in here. The grommet is missing. It does have a new power cord on this. So I'm going to go ahead and get this thing cracked open. We'll take a look at the inside. Okay, I got the unit out of the case, and you only had to take out the top two screws and then 4 under the bottom edge on the front of it. We did have to remove those 2 screws, and as I expected, there's a shielded box for the line cord, and that was soldered all the way. Well, soldered in 2 places here, so I had to remove that solder and get this off. And inside you'll see there's a coil here, and there's another coil here, and we'll need to replace that grommet going through it. There is a grommet here, but it's very hard and will not go back in the hole. So yeah, after doing that, I was able to get the unit out of its case. I'll just stick this back together. Now you can see everything in here is pretty much well shielded. The oscillator is shielded, the power supply is shielded. Pretty much everything on here has its own shield. You can see the attenuator and the variable attenuator are both shielded. A couple of inductors here that are shielded. So now I guess we'll start taking these covers off and get in here and have a look at it more closely. But first, let's take a peek at the schematic. We'll take a quick peek here at the schematic. You see we have a 6A5 rectifier tube, and there's a 6N7 oscillator tube. And there's a tube that's labeled 76. I'll have to look that up, see if I can find where it's at in this piece of equipment, because I don't see any other tube sticking out, so it could be another one inside of one of these boxes. But what really concerns me is looking at the line cord going into the transformer. We can see here on the primary side of the transformer there's capacitor 11 and 12. Now if y'all just watched Paul over at Mr. Carson's lab recent video, piece of equipment he's working on had 2 capacitors that were similar, and they were parted into the transformer. I don't think this will be the case here. Let's hope not. This transformer doesn't look like it would be a parted type anyway. It actually looks open, as you can see here. It just has a metal case on this side, but when we get in there we'll verify that. So I'm gonna go ahead and pull these cases off. We'll probably start over here on this side of the oscillator box and take this shield off, and we'll have a peek in there. Okay, I got all the screws out of the shielded box for the RF section. We can get this out of the way, and here we have our oscillator tube, which is a 76. These tubes was used as detectors, amplifiers, and in this case oscillators. You see we have a big coil here on the back side of the tuning cap, and our band switch here is a bit different than anything I ever seen before. You can see we have a mechanism here that with a ball bearing that falls in these holes to set the band, and the whole assembly rotates. And let me get a better position of the inside where you can see what's going on in here. Now as you can see, this is what you would call very proprietary. each coil is mounted, and you can see the pins on each coil, and as it rotates around, down here in the bottom is a set of contacts that these pins go up against, so it completely takes the coil, out of circuit and puts the next coil in circuit. And if you notice, there's a few of these molded mica caps in here. There's not a lot of capacitors in this unit. It's a pretty nice way of building something. I'm just looking to see if all the tabs are making contact on each pin, and it looks like all 4 of them are. I see them all move when the contact comes around, so no problems in that. Now all these will probably have to be cleaned and a little bit of conductive grease put on them. But yeah, all this is wax coated also. And down here under the tube are several of these square mica molded capacitors. It looks like there's 4 or 5 of them down there. And just hope that they'll be, somewhere within tolerance. I'm pretty sure they used this grade because they were pretty stable back then. Anyway, that's a good look at the inside of the RF shield. So we'll go ahead and pop the power supply off and have a peek on it. I had pulled the top and bottom cover off this power supply, and I immediately got worried when I looked down and I saw all this stuff falling out. And it almost looked like it was some type of bait-like former. And that really had me worried for a minute. And luckily all it was these 2 little transformers in here have a brown coating on them. It's almost like some type of epoxy resin. Sort of has the consistency of bait-like. But yeah, no problems there. So that that kind of worried me for a minute. But yeah, no problem. Now I had to pull the controls and the output jack off the front and remove the light to get this power supply to swing out of the way, so we can get in here and get a better look of what's going on now. Now, lucky for us, unlike the one that Mr. Carson was working on, those 2 capacitors are located right here, and you can see they are both mica capacitors. So we can get them out and get some safety capacitors mounted in here, and they just go from one side of the line cord to ground, and the other one does the same thing. So we can get these replaced with some proper safety caps. Other than changing out these 2, the only other cap that we'll have to replace is this electrolytic up here. Now it's a 2 microfarad and a 4 microfarad, and ground through the chassis and the mounting stud, so we'll have to get that replaced out. Those I'm gonna have to order. I do not have a 2 and 4 microfarad in this voltage range. Well, sometimes you just never know what you're gonna get into when you're taking a piece of vintage equipment like this apart. And I had to remove all these screws, and there's a plate behind this that's bolted on standoffs. We just had to take the nuts out to get this panel out, but the front panel is now out of the way. And it's even neat that they've got a grounding strap here that touches the brass billet here for the tuning dial, and keeps that grounded even though it's isolated from the rest of the chassis. And as you can see, everything is on bait light here. Now let me put this front panel out of the way. So we wanted to look at this shaft and figure out what was going on here, and someone's made a repair to it, and you can see what they've done. It looks like the original part had broke out, so they epoxied in. It was like a control off or something that they cut off into it, but it's in there at an angle. If it wasn't for that, it wouldn't be so bad, but you can see that it's not following the rotation of the whole thing. So probably what I'm going to have to do is get this out and make a new piece to go in there. We'll look around, see what we can find. These two here are pretty much in good shape. The top one, as you can see, was broken off. I do have the broken piece here. There we go, where it broke off, and you can see the insert that's in it. So maybe we can epoxy that back on there, and that one should be fine, because it's just a standoff. It's not a shaft that turns or anything. So yeah, we'll be able to epoxy this one back on. It should be good. This one though is going to require a little bit of work to get that back the way it's supposed to be. And that was one of my main concerns with this piece of equipment here. Alright guys, I got this main tuning capacitor out, and let me tell you, that was a nightmare. Not only do you have these two shafts, you know, you still got the three standoff shafts that go through it. You have three terminals here that are soldered in, and then you have this main wire coming from the tuning cap itself that I couldn't even get to unsolder it, so I had to clip it and then keep working it out. This tube socket here, I thought maybe if I take the screws out I could get it out of the way, but no, it has a big heavy ground that's grounded to the chassis and comes up, and it's grounded to several pins. And just, you know, moving this tube socket was almost impossible. But after a little bit finagling with it, I finally got it out of there. And now we can get around here to look at what we're going to do on this shaft. And I noticed that this thing, it slipped. And you can see, well, I guess you can't see. Okay, but you can see how the repair was done, and you can see just how crooked this is. It looks like it was a good idea, but it didn't quite work out right, because it's not coming out straight. And then it would get so it would slip and wouldn't turn at all. But this piece is just, remember, there it goes. It's just pressed onto this little pin here on this end, and there's no screw or nothing to hold it in place. So that's where it would slip at. And you know, I can understand the reasoning behind that. They say that you don't put nothing in a bind because there's no stops here other than the capacitor itself. So you know, you wouldn't break the capacitor that way. But I'm going to have to see if I can't get this out, take a look at this, and see what we got to do to fix it and get something coming out like it's supposed to be. Should be a fairly interesting repair, so we can get this thing right. So I'm going to be playing with that for a few minutes and see what I can come up with. I got the shaft out of this plastic insulator, or phenolic insulator. It's kind of hard to tell what it's made out of. I think it is a phenolic type of material. But all I've done was took the heat gun and heated the aluminum up, and it just poured right out. And then I got in there and got all the glue out of it. And my thought process was to go back and re-drill this deeper, and put another shaft in it that fit, because this one here is just, you know, is real loose in there. But it looks like to me is that somebody has drilled this by hand, and what they done, as you can see, this side is thicker than this side, so it was not drilled directly in the center. So trying to drill this out the way it is probably going to break. Now I could go here and just cut this off to the depth. You can see the depth here is about a ½ inch. So I could cut it out and try re-drilling it myself and getting a hole in the center and then bringing something out. But then by doing that, we're losing a lot of the strength in this part. So I'm going to have to play around and see what else I can come up. Maybe I can find a piece of material to make a whole complete shaft out of. I don't know yet, but it'll be interesting to find something. Possibly can get this insert out and press it into a new piece. I don't want to use a solid metal piece. I like to keep everything insulated. There's a reason why they did this, and that's to keep signals from going outside the box. So that's why they use this phenolic type of material to do this. Okay, so what I did was cut the end of this shaft off so it would be flush. Found the center, drilled and tapped it at 6/30 seconds. I have this aluminum shaft here. Has a 30-second hole in it. And now we can just screw that right on. And what I'll do, I'll put some epoxy and some Loctite in it so it doesn't come unscrewed. And that should give us the length of the shaft that we need. Okay, I got the RF section put back in, and this side just temporarily stuck in. And I wanted to show you some few things. Now that I know the stuff that I need to pick up to get this thing going, I can go ahead and show you some of the problems that it has. Now I have the generator turned on, unmodulated. And we're pretty much about wide open on the output. We're on band 1. Now what I'm going to do is let you look at the oscilloscope at the signal that's coming out of this machine, and you see it is a useless signal. So let me move the camera. Now I'm using my old analog scope because I do not want to hook this up to the Rigol, and I'm sorry that it doesn't look that great, but you can see, kind of get an idea. It doesn't matter where you put the attenuator or the band or display, this is the signal out, and what that's showing is that's a voltage signal. So here on this output we have voltage. Now it's in the millivolts the way it is, but we know that we do have some bad mica caps in this machine, and I'll show you the reason why. So the machine is sitting on the cable so that it doesn't move around. Got it on AC voltage. We're going to look here across this output, and you can see pretty much no voltage. Now all I'm going to do is reach down, pull this power cord out, and stick it in the other way. So it's out, turn it over, plugging it back in, and this is the part that will get you every time. Let's see what we have across the terminals, and you see nothing. Now what I'm going to do is go into the ground of my power strip, and I'm going to touch the ground, because this is isolated. I'm going to touch the ground of this VNC. Look at that, 121.5 volts. Also, if I go to the internal ground of the machine, 121.5 volts. And there's 121.3 volts on the chassis. So these two mica caps I was showing you, one of them is shorted to ground, and that is the danger of using those style of caps across the power cord. So they will be took out and replaced. Now, like I say, with the cord plugged in the other way, you're changing the polarity. There was no problem at all. You know, only thing you have on your power cord is your hot and your neutral. So there's no ground on this at all. The transformer windings are pretty much open, as you can see on both sides, but these two caps are grounded together and they're grounded to the chassis. So when one shorts, it's going to put voltage on the chassis and on this RF output connector. So it's possible that if you would have grabbed this cable and reached up to plug it into your oscilloscope, and the BNC connector on the oscilloscope is grounded, you are going to get a very, very nasty shock, and possibly overload the front end of your oscilloscope and blow it out. But hopefully, you know, rather blow out the oscilloscope than blow yourself out. So yeah, you always have to be careful with this old equipment like this. Anything that use these floating power schemes in the power supply, you know, be very careful. Be very careful of any of them old capacitors across the line cords. So I'll come in here and desolder those two mica caps that are on the line cords, and I'll go here to ground on our power strip and touch the BNC connector, and you see now we're at 58 volts. And if I pull the AC cord out, plug it back in upside down, and we'll go to ground, we're at 41 volts, and this is AC current. So we have just by removing those two caps, we have taken over half the voltage off the chassis. And if we go up here to the top, you can see on the ground here of the case, we have 41 volts on the case. So that shows there's still some more capacitors in this circuit that are tied to the AC line that is leaking onto the chassis. And we'll have to get all those pulled out and get them replaced. And as I say, you know, that's those molded mica caps, and we definitely do not want this voltage on the cabinet, or it's going to be not only bad for whatever equipment you hook this to, it's going to be bad for your health at all, you know, also. So you have to be careful when you're messing with this old stuff. So I hope you like the first look at the Clough Brengle Model 110 signal generator. I got to go ahead and order a bunch of parts, check the tubes, probably going to get some new fiber washers to go in behind these screws. The VFO turns nice and smooth now. That's one thing I do not like, is that this shaft still, it wiggles, and that's because there's nothing there to hold it in place. So I think what I'm going to do is 3D print a bushing to go into here to hold this shaft solid, so it doesn't wiggle around. It shouldn't be too hard to do. I'll just design it in Tinkercad, print it out on the 3D printer. That should be fine. At least now we do know we have some potential. We have something that can be fixed. So we'll go ahead and probably get that done in a future video. It won't be very soon, but it will be down the road, so keep your eyes out open for that. And I'll leave a link down below for the schematic and the documentation I have on it. I'd like to hear your comments. Leave them down below, and you can also click the show more tab. Follow us on Patreon and over on our website. So until the next video, we'll see you then.